All right, welcome to NextGen Manufacturing Nexus. Today, we're going to pull back the curtain on a process that works quietly behind the scenes, but is absolutely 100% critical for quality. It's called first article inspection, and it's the final gatekeeper before a part ever sees mass production. You know, in the world of modern manufacturing, everything is about speed and volume, but the stakes are just incredibly high. We're in a world where precision is everything. And the smallest mistake isn't just a tiny error, it's a financial disaster just waiting to happen. So let's just cut to the chase. Imagine a really complex part, right? Something for a new jet or a high-performance car. If that very first part is made wrong and nobody catches it, what's the actual damage in dollars and cents? Well, industry studies tell us that the direct cost just for scrap and rework from one single bad part is about $15,000. Think about that. One part, one mistake, 15 grand down the drain. And that's just what you can see on the surface.
Because here's the kicker. The real pain is in the ripple effect. Now you've got million-dollar machines sitting idle, the entire production schedule gets thrown into chaos, and maybe, worst of all, you have a customer who's starting to wonder if you can actually deliver. The true cost is way, way higher.
So, how in the world do you stop that $15,000 mistake before it even happens? Well, the answer is a cornerstone of quality control called First Article Inspection, or FAI for short. So, what is it exactly? Think of FAI as the ultimate checkpoint. It's a super deep, totally systematic review of the very first part that comes off a new production line. The goal is simple. Prove beyond a shadow of a doubt that your process can make a perfect part before you press the big green button on thousands more. And this is a point a lot of people miss. FAI isn't just about, checking if a hole is in the right spot. It's about validating everything. The raw materials, the machine tools, the special coatings, the code running the robot, the whole shebang. Now, a huge part of this process is what's called a ballooned drawing, like you see here. See how every single dimension, every note, every tolerance gets its own unique number in a little circle, or a balloon? This creates a perfect, can't-miss-it checklist for the inspector. Nothing gets overlooked. In critical industries like aerospace, they've actually standardized this whole thing with something called AS9102. It basically tells the FAI story in 3 parts. Form 1 is all about the part's ID. Form 2 tracks all the materials and special processes. And then there's Form 3. The big one, which is the detailed report card where every single one of those balloons gets measured and checked off. So, FAI sounds perfect, right? A totally solid process to guarantee quality. And in theory, it is. But in the real world, the old-school manual way of doing this creates its own giant bottleneck. So if we have this amazing system in place, why do things still slip through the cracks? Where does this supposedly robust process start to fall apart? Well, the answer, unfortunately, comes down to us. It's human error. And this slide, wow, it just perfectly captures the stress of doing this by hand. When people are creating these massive reports manually, it is so easy to miss one little requirement hidden in the corner of the drawing, make a typo, or just not quite measure a tricky curve correctly. Any one of these tiny mistakes can invalidate the entire inspection. This quote from an industry pro really just hits the nail on the head. It is tedious, mind-numbing work. Can you imagine a drawing with 500 dimensions? Now imagine the engineers make a change and you have to do it all over again, making sure every single balloon is still correct. It's just a recipe for mistakes. So here's the big irony, right? The very system that was designed to prevent expensive mistakes was, for decades, a slow, manual process that was wide open to, you guessed it, expensive mistakes. It became a huge bottleneck holding up the entire production line. But this is where the story gets really exciting. That manual bottleneck, it is being completely blown away by digital technology, and it's transforming this entire process. I mean, just look at this. The difference is night and day. On the left, you've got the old way, an engineer with a pen, a calculator, and hours of painstaking work ahead. On the right, the new way, smart software that does the exact same job perfectly in just a few seconds. And this revolution actually started with the hardware. We went from these manual probes, where an operator literally had to touch every single point on a part, to fully automated robotic CMM heads that can measure crazy complex shapes with incredible precision and speed. The hardware got faster, for sure. That was a huge leap. But the true game changer, The thing that finally killed that tedious manual bottleneck we were talking about was the software. This modern FAI software is, well, it's amazing. It uses things like optical character recognition and AI to just scan a drawing, automatically find every dimension and tolerance, and balloon them instantly. It can even compare two different versions of a drawing and instantly highlight what changed. Then it just spits out those perfect error-free AS9102 reports. It's a total game changer. Okay, so what's the bottom line? What does all this fancy tech actually get a manufacturing business? It gets them a massive, measurable payoff in speed, accuracy, and return on investment. Get ready for this number, 80%. That's not a typo. That's how much time companies save on just the ballooning and inspection planning part of the job when they switch from manual to automated. What took hours now literally takes minutes. And this chart just lays it out perfectly. A detailed part inspection that used to take nearly an hour using manual methods can now be completely done in just 5 minutes with a modern system. That is a 10 times increase in speed. So when you add it all up, the faster inspections, less machine downtime, and catching those potential $15,000 scrap parts before they happen, one company did the math. Their annual savings, $213,000. Which brings us to this absolutely staggering number, a 355% return on investment. This technology pays for itself in just over 3 months, and then just keeps pumping massive savings back into the business. The case for it is undeniable. So we'll leave you with this question to think about. In this age of digital everything, is your quality process still a manual bottleneck that's holding you back, or have you turned it into a strategic advantage that speeds you up? The technology to wipe out errors and accelerate your production, well, it isn't science fiction anymore. It's already here.